Welcome to Week 1, Chapter 1.3, Part 1 of 11. Meet Priya. Interning at a regional insurer, her supervisor drops a deceptively simple question on her desk. What is the average wildfire-related claim we pay per policy this season? There is a true answer. One number, mu dollars, buried in the behavior of every policyholder in every dry summer. But Priya cannot see it. She sees only the claims that came in, a spreadsheet of 200 numbers. She averages them, gets $8,410, and writes it on a sticky note. The real question of this chapter is deeper than it looks. Let us frame the problem. Somewhere, there is a true average claim, mu dollars, fixed, real, unknowable. Priya cannot observe it directly. All she has is one sample of 200 claims that actually came in. She averages them and gets $8,410. Now, the honest question is not, is this the right number? She will never know the right number. The honest question is this: if the universe had handed her a different 200 claims, same insurer, same season, same underlying risk, just a different draw of which policies happened to file, how different would her sticky note be? If a redraw would have given her 8,390, the figure is solid. If a redraw could plausibly have given her 6,000 or 11,000, then 8,410 is barely more than a rumor. That what-if question is the entire content of this chapter. Here is the most important sentence in the chapter. An estimator is a random rule for turning data into a guess. An estimate is the one number you get when you feed that rule the data you happen to have. The estimator is the recipe. The estimate is the cake you bake today. Confusing the two is the single most common conceptual error in empirical work. Priya's recipe is, add up the claims and divide by how many there are. The sample mean, x bar equals 1 over n, times the sum of the x sub I. Now notice what kind of object x bar is. Each claim before the season plays out is a draw from some distribution, a random variable. A function of random variables is itself a random variable. So x bar is random. It has an expectation, a variance, and a whole distribution of its own. The number 8,410 is not random. It already happened. It is one realized value of x bar, the way 4 is one realized value of a die roll. That realized number is the estimate. To summarize Part 1, an estimator is the random rule for turning data into a guess, and an estimate is the single number that rule returns when you feed it today's data. The sample mean is a random variable with a whole distribution of its own. 8,410 is just one realized draw of it. In Part 2, we will see that the sample mean is only one of many possible recipes, and we will name the three words we use to judge them all: bias, variance, and mean squared error.